I am Anil Kumar. Welcome to my series on Pythagorean Theorem. In this video, we'll focus on the converse of Pythagorean Theorem. In case you want to learn from me on online classes, you can always contact me via the email address given here. Also check my website for the latest videos. Let me begin with the Pythagorean theorem itself, which states that in a triangle ABC, where C represents the hypotenuse and A and B represent the legs, C square equals to A square plus B square. So if we take a right angle triangle, let us say this is a right angle triangle. In that case, sum of squares of A and B is equal to C square, right? So that is what we're trying to say. Normally, when we label a triangle, in that case, the vertices and the sides opposite have the same letter. Vertices are written in uppercase, A for example, and the side opposite in lowercase a, as you can see here. B, the side opposite to B will be lowercase b, and side opposite to C will be lowercase c. That's the nomenclature. So in a triangle ABC, where C is the right angle, a square plus b square is equals to c square. Side opposite to the right angle is the longest side, and it is also called hypotenuse, correct? So that is your hypotenuse. These are the legs. You can see leg 1 and leg 2. So it has two legs, the shorter sides, and a hypotenuse. Now, what is the converse of Pythagorean theorem? Let's look into that part. So conversely, if I am able to say that a square plus b square is c square, in that case, again, it is a right angle triangle. Makes sense. But not only that, we can derive more things from what a square plus b square is and how it is related with c square. And therefore, let's focus on this particular term, the converse of Pythagorean theorem. In a triangle ABC, when c is the longest side, c square equals to a square plus b square, then the triangle is a right angle triangle. That means angle C is 90 degrees. Only if c square is equal to a square plus b square. Well, there could be other conditions. C square could be greater than or even less than a square plus b square. In that case, what? We can conclude that. Perfect. So, this also implies that if c square is less than a square plus b square, then angle C is less than 90 degrees. That means we're looking at an acute angle triangle. Perfect. If c square is equal, then of course it is a right angle triangle. But if c square is greater than a square plus b square, then angle C is greater than 90 degrees, and we are looking at obtuse angle triangle. Correct? So we could conclude this. So converse is very important also to decide what type of triangle are we working with. Based on this, we have three questions. So let's focus on these three questions now. Question number one, classify the following triangle with given side lengths. So there are four sets of side lengths given to us. You can now classify them as an acute triangle, right triangle, or obtuse triangle. And the strategy is find a square plus b square, compare with c square. Question number two here is, given an acute angle triangle ABC with integer values as the length of the sides, if the two side lengths are 10 centimeters and 14 centimeters respectively, find all possible lengths of the longest side. Right? So we are given an acute angle triangle and we need to find all possible lengths of the third side when two sides are given to us. Now this question is modified, and The same question is put for obtuse angle. Now the question becomes, given an obtuse angle triangle ABC and the integer values of two sides same lengths as previous, find all possible lengths of the longest side. So that becomes our question number 3. I'd like you to pause the video, answer these 3 questions, and then look into my suggestions. Now let's begin with the very first one, which is we need to classify the following triangles with given lengths. Right. So what I've done here is made a table. So in the table, we'll add the squares of these legs, I should say the smaller sides, and compare that with the square of the longest side. That helps us to decide what kind of triangle it is, correct? So taking the very first one, the two smaller sides are 6 and 8. 6 square plus 8 square is 100. What is 9 square? Well, 9 square is 81. Since 9 square is less than 6 square plus 8 square, it should be an acute triangle. Does make sense to you? That is how we will easily prove it. Correct? Now let's take B. The two shorter sides are 5 and 12. 5 square, 12 square gives us 169. And 13 square is 169. They're exactly same. And therefore, that should give you a right triangle. Since C square is equals to A square plus B square. So this is a right triangle with the side lengths of 5, 12, and 13. Now C is, we have two side lengths which are 10 and 12. So 10 square plus 12 square gives us 244. And what is 16 square? Well, 16 square is 256. Now 256 is greater than 244, and therefore that should be an obtuse triangle. Does make sense to you? Perfect. The last one is slightly tricky. We again did the same thing. 7 square plus 9 square is 130 and 17 square is 289. Now if you compare these two, then from here we can say that 289 is greater than 130. You may say it is obtuse, but that will be a wrong answer. You know why? It is very important to understand that in a triangle, whenever you make a triangle, sum of two sides is always greater than the third side, right? So if you have a triangle, which is, let us say, A, B, and C, in that case, A plus B should be greater than C. This is also important to understand. Now, in this particular case, the two sides are 7 and 9. So if you add 7 and 9, you get 16. However, 16 is less than 70. You see that? So therefore, you cannot form a triangle. So no triangle. Do you understand? So that is why it is slightly tricky. So that's the reason. So triangle is not possible as the sum of two sides is less than the third side. 7 plus 9 is less than 17. And therefore, in this case, no triangle is formed. Do you see that? So the third case is a case when triangle is not possible. And therefore, you cannot classify this as an acute angle, obtuse angle, or a right angle triangle. You get the idea, correct? So this is very important. So you need to look into all these aspects while solving such a question. Now let's look into question number 2. Question number 2 here is, given an acute triangle, so we are already given acute triangle ABC with integer value of the sides. If two of the sides are of length 10 and 14 centimeter respectively, find all possible lengths of the longest side. So here we are given two sides. So let's make, for example, one could be like this, right? So we have a side length which is 10 units and the other as 14 units, right? So I could write the side lengths as, let us say, 10 and 14. Now, this is an acute angle which is less than 90 degrees. So you can see that we could have different lengths of the third side. Is that clear to you? I could also have a triangle which is kind of like this. Now in this case, the third length will be longer. right? So with the same 10 and 14 as the given two sides. So there are many different triangles possible. Now let's look into the question once again. If two of the sides lengths are 10 and 14 centimeter respectively, find all possible lengths of the longest side. So we are assuming that the third side is longer and we need to find all possible lengths and acute angle. So how should we do it? Well, the strategy is simple. First, we need to ensure that it is an acute angle. So acute angle triangle means that c square should be less than a square plus b square. So when I do 10 square plus 14 square, we get 296. The square root is 17.2. Now clearly, if 17.2 is the upper limit of C. In that case, the lengths are what? Less than 17, right? They could be 17, 16. Now, the other two sides are 10 and 14. So at the most, it could be 15. And therefore, these three lengths are possible. So there are three solutions to this, right? So we have three solutions. And we know what the solutions are. All possible values of the length for the longest side are 12 centimeter, 15 centimeter, 16 centimeter, and 17 centimeter as shown here. So I hope you have understood the concept, correct? Now we have a variation on this particular question, and the variation is this time we are given obtuse triangle ABC with the same lengths 10 and 14. We need to find all possible lengths of the longest side. So we'll do exactly the same thing. C square has to be greater than a square plus b square. That means this time C is greater than 17.2, right? So we know that C is greater than 17.2. However, how do you find the upper limit? That is the question. Earlier, we had the lower limit since we knew that it has to be greater than 14. Now, in this case, will it be like all the values above 17.2, like 18, 19, 20, 21? What is the upper limit? That is a question to be answered. Well, the upper limit is decided by 10 plus 14, correct? 10 plus 14 is 24. So 24 is the upper limit. We cannot go beyond 24 as we know that sum of two sides, any two sides, is always greater than the third side. Is that clear to you? So taking that into consideration, we know the highest value should be 14 and therefore the possible values are above 17.2, above 17.2 is 18, then 19, 20, 21, 22 and 23. So these are the six values possible. So we know that the value of C has to be less than 24 and greater than 17.2. Therefore, the integer values are 18, 19, 20, 22, 21, 22, and 23. Is that clear to you? So that is how we can actually use the converse of Pythagorean theorem to solve such questions. I hope you find them interesting and useful. As I said, you can always contact me on this given email address to learn more. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.